In the last video, we looked at the introduction of the continuous distribution function. In this video, we will look at how a practically viable continuous distribution function will look like. In other words, we will look at the nature of a continuous distribution function. We have seen in the previous video that the sum of the probabilities of all the possibilities is 1. In other words, there is a 100% probability that at least one of all the possible events of a scenario will happen. Let's discuss this with few examples. What is the probability that a coin will toss a head or a tail? What is the probability that a dice will throw a 1 or a 2 or a THRE or a 4 or a 5 or a 6? There is 100% chance, and in fact there is no other possibilities but those mentioned ones in these scenarios. And, we know that a 100% probability means in fractional form, the probability is 1. How do we formulate what we just discussed? Read only, we formulate by stating that a practical distribution function satisfies the following equation. Let A through B be the set of all possible values of x. Then the summation or the integration of all the probabilities between these limits has to be 1. Let us express the same through this integration equation. Also, since any probability is always less than 1. For any x, f of x is always less than 1. These two are guiding principles for many problems we face in examinations. We can express the distribution in 3 formats, either an equation, a table, or a graph as shown. Let us also verify what we just discussed using the previous examples. Here, in this case, let dx equals 1. We have 6 such small intervals in this case. The interval from 0 to 1. The interval from 1 to 2. The interval from 2 to 3. The interval from 3 to 4. The interval from 4 to 5. And, finally, the interval from 5 to 6. Now, let's multiply the range lengths with the probability density function.